We have built galvanized wire mesh cages and filled them with stones to protect our sedimentation pond and sedimentation tank from high river waters and to control the flow of water we need for the PICO-HYDRO Power Turbine plant. They lead debris, wood branches and stones to one side and just let the required amount of clean river water through to the sedimentation pond. Only the needed amount of river water gets through. Only clean water is going through the sedimentation tank. We open only as much as we need. Like this, we clean the sedimentation tank water surface from small debris, dirt and leaves every day to protect the turbines from obstacles. The 2 meter long, 200 mm thick HDPE pipe acts like a filter to protect the turbines from unwanted debris. You can see small wood particles and leaves are held up by the filter. We clean the filter like this every day, keeping the turbines safe. Through the 200 mm HDPE filter pipe, water flows down to the turbines. Any excess water and any on the surface floating small debris will flow through the two 180 mm diameter HDPE overflow pipes, keeping the water in the sedimentation tank clean and safe for the turbines. From here, the water flows down to the turbine house through a 200 mm diameter HDPE penstock. The ground level is up and down, never equally sloped. We have placed the penstock accordingly, sometimes on a stone wall. Here we constructed a strong stone wall for the penstock. The total length of the penstock pipe is 490 meters, with a difference in height of 50 meters with 3 meter head loss, resulting in a net head of 47 meters or 4.7 bar pressure. Inside we have 6 Pelton turbines running. The Modular PICO-HYDRO Power Plant has 6 Pelton turbines and is the first of its kind in Nepal. Though one turbine would meet the village's electricity demand today, we installed 6 turbines to prove the concept of modularity, which means the hydropower plant can grow along with the village's power demand increase and ability to pay for the electricity generated over the years to come. Once a month, we grease each turbine's bearing rolls. Once a month, we stop and clean each turbine one by one. If we stop one, the other 5 will keep on generating power. Now we will open the plexiglass window and check the turbine's condition. I spin the Pelton turbine runner to check if it runs free and smooth, or if there is increased friction or metallic noise due to increased bearing friction. The maximal water flow for all 6 turbines is approximately 20 liters per second, with 47 meter head, generating 6.6 kilowatts electricity. The water flows after the turbines from the turbine house to the outflow back into the river through a 30 meter long, 225 millimeter diameter, 2.5 kilogram per square centimeter underground buried HDPE pipe. Inside this box, all the power is joined and conditioned to be sent via 300 meter long underground buried armored cable as 300 volt DC power to the powerhouse in the village. We don't need any wooden or metal poles. The power is transmitted underground to the powerhouse. From the turbine house to the powerhouse, the 300 meter long armored cable is half a meter deep buried. From the turbine house to the powerhouse, we have laid an underground buried armored cable 500 millimeter underground so that the farmers can plow, plant and grow their crops, be it wheat, barley or potatoes, anytime without a problem. The buried armored cable does not disturb the farmer in any way. He can plow his fields with his bulls, can plant potatoes, vegetables or wheat, plant apple trees, and cultivate the land in any way he wants without any hindrance. The power transmission cable comes from the turbine house up to the powerhouse here. From here, the cable continues underground along the toilet and hot water shower room into the power room. This is the powerhouse with all the power conditioning, management, and distribution equipment. This is the armored power cable which comes underground from the turbine house, transmitting the generated power as 300 volt direct current. All the power comes through a maximum current breaker fuse box into the power room. L1, L2 and L3 we call Phase 1, Phase 2 and Phase 3. For the 230 volt AC electricity distribution line, we consider the village has two parts, one in the east and the other in the west. Electricity transmitted to the western side of the village is controlled with this MCB, and the electricity transmitted to the eastern part of the village is controlled with this MCB. Further, we have two water heating systems to take showers for improved personal hygiene. These are smart dump loads, heating water whenever there is more power available after the village's electricity demands have been met. This PC is in particular for the prepayment pay-as-you-go system. That means that each family has to come at the beginning of every new month and pay for the electricity in advance so that they can have uninterrupted electricity throughout the coming month. When no balance is left, the user has to purchase again a new token in order to have uninterrupted access to electricity. When the village uses less power, the computer system recognizes that immediately and diverts the leftover power to different smart dump loads, such as the room heaters in the community house, heating up the rooms for better comfort. If there is still more excess power available after all priority energy demands have been met, a high-altitude biogas digester plant is heated inside to improve the anaerobic digestion process to produce more biogas. The main objective of the community and powerhouse built by RIDS-Nepal is that the community can learn through awareness and skill-based trainings. Further studies and research can be carried out in the field of holistic community development and applied renewable energy technologies by national and international students. The community center serves as well for visitors and tourists interested in coming to Nepal to experience firsthand in a new way the differences and values of an intercultural way of life in the midst of the unique ecosystem of the high-altitude Himalayan mountains.